Hi everyone, it's Albert here. Today let's solve the contest question, maximum non-negative product in the matrix. The question statement, so given a matrix grid and initially we are standing at the top left corner and each step we're only allowed to move right or down in the matrix. And among all possible paths starting from the top left corner and ending in the bottom right corner, we have to find the path with the maximum non-negative product. And the product of a path is defined as the product of all integers in the grid visited along the path. So for example 1, there's no any path that will get a non-negative product. So in this case, we will just return a -1. And for example 2, there's a path which is bolded on the grid here that will get the maximum product 8. So for example 2, we will return 8. And if you have been following my videos, you will notice that this question is very similar to a question we have solved before, which is 1567, maximum length of subarray with positive product. And the algorithm we will use is also dynamic programming. And the foundation to solve this question is 152, maximum product subarray, and the very classic DP question, the 62 unique paths. And the data structure we will use are two DP matrix, which is DP max and DP min. And they stand for the maximum and minimum prefix product up to the current cell. Now let's look at the code. Okay, and there's basically 3 parts of the code. The first part is to initialize the DP matrix, DP max and DP min. And their size is the same as the input grid. And we will set DP max 0, 0 and DP min 0, 0 to grid 0, 0. And next is to initialize the first row and column of both DP max and DP min. And their values is basically the prefix product along the row and the column. And the last part is the DP transition. So for DP max, the value of every cell, it can be the maximum among 4 values, which is grid RC times the left cell of DP max or the top cell of DP max, or grid RC times the left cell of DP min and the top cell of DP min. And we will see later why we need to include DP min into the calculation for DP max later. And for DP min, this will be the minimum among these 4 values. And the last cell of DP max, which is the maximum product of all paths, will be the answer. So now let's try to visualize this process. Okay, and here we'll be looking at example 2. And I have DP max and DP min matrix on the screen here. So the first row and column, they're basically the prefix product along the row and column. So which is 1, -2, -2, and 1, 1, 3. Now let's start to update the inner cells. So the first value in grid is -2. And because in each step, we're only allowed to move right or move down. So in DP max and DP min, the values will be updated either from top or from left. So the product from the top cell is 4, which is a -2 times -2. And the product from the left is -2 times 1, which is -2. And for DP max, we'll put the maximum value among these 4 possible values, so which is 4. And DP min, we'll put -2 here. Okay, and moving to the next value, which is 1. So the product from the top cell is -2 in dpmax, and from left is 4. For dpmin, it is -2 from top cell and -2 from left cell. So the value in dpmax will be 4, and it will be -2 in dpmin. And here comes the interesting part. So the value in grid is -2. So in dpmax, the product from the top cell is -16. From the left cell is -12. And in dpmin, the product from the top cell is 8. From left is -12. So the maximum among these 4 values is 8. So we will put 8 in dpmax. And the minimum is -16. So it's -16 in dpmin. So you can see that in this case, the value in dpmax is actually updated from the product in dpmin. So that is the main reason we also have to keep a dpmin matrix along all paths. Okay, and finally is the last cell. Its value is 1. So following the same process, we will get 8 in dpmax, and this will be the answer. Finally, let's review. So the key algorithm to solve this question is dynamic programming. And make sure to review the questions 1, 5, 6, 7, and also the foundation questions 1, 5, 2, and 62. And the key data structures we use in these questions are 2 dp matrix, dpmax and dpmin. And the main purpose of dpmin is to keep the most negative product along the way, because the most negative product might become the maximum positive product later on. And time and space complexity for this solution are both big O of m times n, because we have to loop through the whole matrix. And that will be all for today. Thanks for watching. If you like this video, please give it a like and subscribe to my channel, and I will see you in the next one.